Hi guys, welcome to this video looking at how to calculate the concentration in both grams per decimeter cubed and moles per decimeter cubed, as well as converting between the two. Okay, let's make a start. To calculate the concentration in grams per decimeter cubed, you need to remember this triangle that you can see here. It shows you that the concentration in grams per decimeter cubed is the mass in grams divided by the volume in decimeters cubed. Now, to convert centimeters cubed into decimeters cubed, you need to remember to divide by 1,000. Let's see the calculation in action then. 32 grams of sodium chloride is dissolved in 4 decimeters cubed of water. Calculate the concentration of the solution. So, from our triangle, we can see that the concentration is mass in grams divided by the volume in decimeters cubed. I have both of these bits in the question, so therefore the concentration is simply 32 grams divided by 4 decimeter cubed, which if I type that into the calculator is 8 grams per decimeter cubed. Simple, right? The only way they can complicate this calculation is to give you a volume in centimeters cubed. So this question says 0.5 grams of lithium nitrate is dissolved into 200 centimeters cubed of water. Calculate the concentration of solution, again, in grams per decimeter cubed. I've got the mass, 0.5 grams, and I've got the volume, but it's in centimeters cubed. So to convert between centimeters cubed and decimeters cubed, you divide by 1,000, which is 200 divided by 1,000, giving me 0.2 decimeters cubed. Therefore, my concentration is 0.5 grams divided by 0.2 decimeters cubed, which comes to 2.5 grams per decimeter cubed. On to the next section of this video then. To calculate the concentration in moles per decimeter cubed, you need to remember this triangle. It shows you that the concentration in moles per decimeter cubed is the moles with the unit mol divided by the volume in decimeters cubed. To convert centimeters cubed into decimeters cubed, don't forget you need to divide by 1,000. And then usually for this question they will give you the moles, unless it's a much higher level question. It may in this instance ask you to work out the moles as well, which is mass divided by formula mass, as you can see in this triangle here. If you can't remember the mole calculations, look at the video in the top right now. Let's see this calculation in action then. So my question says 0.1 moles of lithium nitrate is dissolved in 4 decimeters cubed of water. Calculate the concentration of the solution in moles per decimeter cubed. So nice and simply, we have the moles, 0.1, and the volume, which is 4 decimeter cubed. So the calculation is moles divided by volume, which is 0.1 divided by 4, which comes out to 0.025 moles per decimeter cubed. If we look at a slightly more complicated question, which states that 0.1 moles of sodium sulfate is dissolved in 250 centimeters cubed of water, calculate the concentration in moles per decimeter cubed. Again, we have the moles, which is 0.1, and the volume, which is 250 centimeters cubed, but we must convert this to decimeters cubed. So to do this, we divide by 1,000, so 250 divided by 1,000 comes out to 0.25 decimeters cubed. I can now work out the concentration, which is moles divided by volume, which is 0.1 divided by 0.25, and my answer is 0.4 moles per decimeter cubed. Let's look at a rearranging question then. Calculate the volume in centimeters cubed containing 0.04 moles of iron chloride with a concentration of 0.1 moles per decimeter cubed. So here we have the concentration and need the volume. Using our triangle we can see that the volume is moles divided by concentration. We're given the moles in the question, which is 0.04. We're also given the concentration, so we can work out the volume, which is 0.04 moles divided by 0.1 moles per decimeters cubed. This gives me an answer of 0.4 decimeters cubed. However, the question is asking for the volume in centimeters cubed. We know that to go from centimeters to decimeters cubed, you divide by 1,000, so to go the other way, we need to multiply by 1,000, which is 0.4 times by 1,000, coming out at 400 centimeters cubed. Okay, last question on calculating the concentration in moles per decimeters cubed. Let's step the difficulty up again. This one says that 4.6 grams of hydrochloric acid, HCl, is dissolved in 500 centimeters cubed of water. Calculate the concentration in moles per decimeter cubed. So we want to know the concentration. We can easily work out the volume, which is 500 centimeters cubed divided by 1000, which comes to 0.5 decimeter cubed. However, we haven't been given the moles in the question. How can we work that out? This is where that other triangle comes in, which you can see here. We have the mass, which is 4.6 grams, and we can work out the formula mass, which is just the atomic masses added together. So we have one hydrogen with an atomic mass of 1, one chlorine with an atomic mass of 35.5, giving me a formula mass for hydrochloric acid of 36.5. Therefore, my moles calculation is mass 4.6 divided by formula mass 36.5, giving me 0.126 moles. We now have the moles, so we can go back to the original triangle and add the moles in. Concentration is moles 0.126 divided by volume, which was 0.5, giving me a concentration of 0.252 moles per decimeter cubed. Now, this is obviously a lot more complicated than the other questions you've seen. There is another simpler way to do this, which involves converting between grams per decimeter cubed and moles per decimeter cubed. So let me show you how we do that. Right, how do you convert between grams per decimeter cubed and moles per decimeter cubed? To start off with, you need to learn this triangle. This shows you that to convert to grams per decimeter cubed, you need to multiply the concentration in moles per decimeter cubed by the formula mass, which hopefully you can remember is just the addition of all the atomic masses. It also shows you that to convert to moles per decimeter cubed, you need to divide the concentration in grams per decimeter cubed by the formula mass. So if we go back to the question we saw earlier, the one that said 4.6 grams of HCl is dissolved in 500 centimeter cubed of water, the first step is to work out the concentration in grams per decimeter cubed, which hopefully you can remember is mass divided by volume, so 4.6 grams divided by 0.5 decimeters cubed. This gives me an answer of 9.2 grams per decimeter cubed. Next, we need the formula mass, which we worked out earlier, one hydrogen, one chlorine, giving me a formula mass of 36.5. So now all I need to do is convert from grams per decimeter cubed to moles per decimeter cubed, which is grams per decimeter cubed, which we worked out as 9.2, divided by formula mass, which is 36.5, giving me an answer of 0.252 moles per decimeter cubed, which we saw earlier. Okay, let's look at another simpler question. It says calculate the concentration in moles per decimeter cubed of 240 grams per decimeter cubed of sulfuric acid, H2SO4. So I've been given the concentration in grams per decimeter cubed here. All I have to do is work out the formula mass and then convert it. If we start with the formula mass, I have two hydrogens, so 2 times 1 is 2. I have one sulfur, so 32, and I have 4 oxygens, so 4 times 16 is 64. This gives me a formula mass, if we add it all together, of 98. Next step is the conversion. I need to divide grams per decimeter cubed, 240, by formula mass, 98, which comes out to 2.4 moles per decimeter cubed. And that's my answer. Okay, I have one final question for you before you get to have a go. It says calculate the concentration in grams per decimeter cubed of a 400 centimeter cubed solution containing 0.2 moles of nitric acid, HNO3. So we need to pick this question apart. The first thing we can do is work out the concentration in moles per decimeter cubed, because we've got the moles and we've got the volume. We can also work out the formula mass, and therefore we can convert to grams per decimeter cubed. So step 1, let's work out the concentration in moles per decimeter cubed, which is moles, 0.2, divided by volume in decimeters cubed. So to get it into decimeter cubed, I need 400 centimeter cubed divided by 1000, giving me 0.4 decimeter cubed. Therefore, my concentration is 0.2 divided by 0.4, giving me a concentration of 0.5 moles per decimeter cubed. Step 2, let's work out the formula mass. I have one hydrogen with a mass of 1, one nitrogen with a mass of 14, and 3 oxygens, so 3 times 16 is 48. Add that all together and I get a formula mass of 63. And then the final step, Converting to grams per decimeter cubed, I take my concentration in moles per decimeter cubed and multiply it by the formula mass. So 0.5 times by 63, which gives me an answer of 31.5 grams per decimeter cubed. That really is everything you need to know for this video. However, if there's anything you're not sure on, please feel free to ask any questions in the comments and I'll reply as soon as I can. Let's have a look at a few questions then. We'll start off with some questions looking at concentrations in grams per decimeter cubed. Have a read through these questions, pause the video and have a go. As soon as you're ready, press play and we'll go through. Okay, let's go through then. So this question is asking you to calculate the concentration in grams per decimeter cubed. The first mark is for converting the volume into decimeter cubed. So to do this, we divide 500 centimeters cubed by 1000, giving us a volume of 0.5 decimeter cubed for 1 mark. The second mark is for the concentration calculation, which is mass divided by volume, so 5 divided by 0.5, giving me 10 grams per decimeter cubed for our second mark. Next question. This one asks you to calculate the volume in centimeters cubed, so it means you need to rearrange the calculation. Start off with working out the volume in decimeters cubed, which is the mass, 10 divided by the concentration, which is 32.5 grams per decimeter cubed. This comes out to 0.308 decimeters cubed to 3 significant figures, getting you the first mark. To get the second mark, we have to convert back to centimeters cubed, so you need to multiply by 1000, which gives you an answer of 308 decimeters cubed. Now let's move on to some questions looking at concentration in moles per decimeter cubed. Have a read through these questions, pause the video and have a go. As soon as you're ready, press play and we'll go through. Okay, let's go through then. This question asks you to calculate the concentration in moles per decimeter cubed. The first mark is for converting the volume into decimeters cubed, so divide 750 by 1000, giving you a volume of 0.75 decimeters cubed for your first mark. And then the second mark is for the concentration calculation, which is moles divided by volume, so 3 divided by 0.75, giving you 4 moles per decimeters cubed for your second mark. Next question. This question asks you to calculate the moles, so it means you need to rearrange the calculation. Start off with working out the volume in decimeters cubed, which is 400 centimeters cubed divided by 1000, giving you 0.4 decimeters cubed for your first mark. To get the second mark, we have to multiply the concentration by the volume, so 1.2 moles per decimeter cubed times by 0.4 decimeters cubed gives you 0.48 moles to 2 significant figures. Finally, let's look at some questions involving the 2 types of concentration. Have a read through these questions, pause the video and have a go. As soon as you're ready, press play and we'll go through. Okay, let's go through then. This question asks you to calculate the concentration in grams per decimeters cubed and gives you the concentration in moles per decimeter cubed, so you should realise it's a conversion calculation. Step 1. Work out the formula mass. Even if you can't do the rest of these conversion calculations, you can pick up marks for getting this simple technique right. So we have 1 copper with a mass of 63.5, 1 sulphur with a mass of 32, and 4 oxygens, each with a mass of 16, giving me 64 in total. Add this all together and we get 159.5 for your first mark. The second mark is for the conversion, so concentration in grams per decimeter cubed is moles per decimeter cubed multiplied by formula mass, so 0.5 from the question multiplied by 159, which we just worked out, giving you an answer of 79.75 grams per decimeter cubed for your second mark. Next question. This question asks you to calculate the concentration in moles per decimeter cubed and gives you the concentration in grams per decimeter cubed, so it's also a conversion calculation. So step 1, formula mass. We have 1 lithium with a mass of 7, 1 nitrogen with a mass of 14 and 3 oxygens, each with a mass of 16. Add this all together, giving us a formula mass of 69 for 1 mark. The second mark is for conversion, so concentration in moles per decimeter cubed is grams per decimeter cubed divided by formula mass. So 120 grams per decimeter cubed from the question, divided by 69, which we just worked out, giving you an answer of 1.74 moles per decimeter cubed for your second mark. On to the final question then. This is a much more complicated question, bringing in everything you've learned about concentration calculations. We are looking for the concentration in moles per decimeter cubed, but have a few steps to get there. Okay, so we have a volume in centimeters cubed. Start by converting that into decimeters cubed. So 750 divided by 1000 gives 0.75 decimeters cubed for 1 mark. With that, we can work out the concentration in grams per decimeter cubed, which is 5 grams from the question, divided by 0.75, which we just worked out, giving you a concentration of 6.7 grams per decimeter cubed for your second mark. Next, you need to work out the formula mass. We have 1 copper with a mass of 63.5, 2 nitrogens, which is 2 times 14, giving a mass of 28, and 6 oxygens, so 16 times 6 giving 96. Add these all together, giving you a formula mass of 187.5 for your third mark. Finally, we need to convert grams per decimeter cubed into moles per decimeter cubed. To do this, we divide the grams per decimeter cubed by the formula mass, so 6.7 divided by 187.5, giving you a final answer of 0.036 moles per decimeters cubed. And there we have it. Hopefully that's all made sense. As I said earlier, if anything confuses you, let me know in the comments and I'll try and clarify. I have got a review question for you, so have a read through, have a go, and let me know your answer in the comments, and I'll tell you if you're right. Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can also subscribe to my channel, you can check out the latest video, and you can visit my website up above here. Bye now.